So hello future achievers, welcome back to this free hit channel, okay, where we post daily videos for you to complete the syllabus of physical chemistry, okay. And in this session we are actually going to discuss is laws of gases and Avogadro's hypothesis, okay. So now let's understand laws of gases. First of all, I will just tell you my name. My name is Ritik Singh. I am your physical chemistry faculty, okay. Now we have laws of gases, okay. So first of all, let's go through some what you call it definition, okay. We have to go through definition. Let's see what the definition say, and then I will make you understand something, okay. So it's not okay. So what is the definition? Law of gases. It says that when gases react, okay, so when some gases are reacting, okay, they do so in the volume. So they are doing so in the volumes that are in the whole number ratio. So when some gases are reacting, okay, so suppose hydrogen and oxygen is reacting. So suppose hydrogen and oxygens are reacting to form what? Suppose it is forming water, okay. So when these gases are reacting, they do so in the whole number ratios to one another and to the volumes of the products. So whatever these what you call it, these elements, when they are reacting with each other to form a compound, okay, so they are doing it in a whole number ratio of their volumes. So suppose if we balance this equation, can you tell me, this will be half, right? Just to balance this equation, there should be a half over here, okay. Now they must be reacting, okay, in a whole number ratio to their volumes, okay. For an example, can you see what is the stoichiometric ratio? So stoichiometric ratio is 1, half, and again 1, okay. So these are the stoichiometric ratios with which these gases are reacting. So they will be reacting, okay, in terms of volume with same of these whole number ratios, okay. So if we try to convert these ratios into whole number, so this is half, this is 1, so we can say it is also 2:1:2, okay. This is the same ratio, this is the same ratio, okay. So it means these gases are reacting in a whole number ratio to form a product, okay. Got it? Under the same temperature and pressure conditions. So remember, the temperature and pressure conditions should be same, okay, for this to happen. Got it? This is the law of gases volume. I hope you understand, okay. Now let's do two questions, one from NEET and one from JEE, to understand this concept, okay. So we have one question over here from NEET 2022, okay. Now it is asking us, one volume of nitrogen reacts with volume of hydrogen to form how many volumes of ammonia? So one volume of nitrogen is reacting with 3 volumes of hydrogen. How much ammonia will be formed? Let's see. Do we know when N2, okay, it reacts with, what do you call it, when N2 reacts with hydrogen to form ammonia, right? This is the reaction, okay, but this reaction is not balanced. So when you balance the reaction, you will see, okay, nitrogen is 1 atom over here, nitrogen is 2 atom over here. It means we have to multiply this number by 2, okay. Now hydrogen is 3 into 2, it means 6 atoms over here, but only 2 atoms over here. So we have to multiply this thing by 3. Got it? Now we have a good equation. So this equation is now balanced. Now see what it is asking. One volume of nitrogen reacts with 3 volume of hydrogen to form how many moles of ammonia, okay. So for an example, can you see what is the stoichiometric ratio? So this is 1:3:2, okay. So 1 volume of nitrogen, okay, reacts with 3 volume of hydrogen to form how many moles of ammonia? Exactly, that is 2 moles of ammonia. I hope the question is understandable, right? Okay, now we can move forward to the next question. This question is from JEE 2021, okay. Now let's read the question. If 100 milliliter of hydrogen combines with 50 milliliter of oxygen, okay, what is the resulting volume of water vapor? So we need to find how much water vapor will be formed, okay, how much milliliters of water vapor will be formed after hydrogen reacts with oxygen, okay. Same way, laws of gases volume, it is again simple, okay. So see, first of all, write the equation. When hydrogen combines with oxygen to form the water, what is the equation? So hydrogen is combining with oxygen to form what? It is forming water. Got it? Now Right now the equation is not balanced, we have to balance the equation. Okay, so now oxygen is 2 over here, oxygen is 1 over here, so we have to multiply it by 2. Now hydrogen is how many? 2 hydrogen atoms into 2, that is 4 hydrogen atoms here and 2 hydrogen atoms here. So how many hydrogen atoms are there? We have to multiply it by 2. So I hope the equation is balanced, right? H2 plus O2 is equal to H2O. Okay, so 2 times this and 2, got it. Now it is asking if 100 milliliter of hydrogen. So first of all, see the stoichiometric ratio. Stoichiometric ratio is 2 is to 1, okay, is to 2. Okay, it means twice the volume of hydrogen once the volume of oxygen will combine together to form twice the volume of water. 2 milliliter. Suppose how much? 2 milliliter of hydrogen combines with 1 milliliter of oxygen to form 2 milliliter of water. Okay. Then in the same way, 100 milliliter. Can you answer me? 100 milliliter, okay, of hydrogen combines with 50 milliliter of oxygen to form what is the resulting volume of the water vapor. So then how much volume of water vapor will be formed? So 2, 1, 2, 150, 100, simple. Got it? You need to go with the ratio. Okay, so 100 milliliters of water will be formed. So our answer is option number 2. I hope this question was understandable. Okay, you will get this PDF and now you will be able to answer this yourself. Okay, let's go on to our next topic, that is Avogadro's hypothesis. Okay, so what is Avogadro's hypothesis? It says that at the same temperature and pressure, equal volumes of all gases. So whatever whichever gas you take, hydrogen, oxygen, nitrogen, you pick out equal volumes from all of them. Okay, maybe 1 liter, 1 liter, 1 liter from every gas. The fact is that if you take out equal volumes of all gases, they will always contain the same number of molecules. It means the number of molecules in each of these equal volumes of different gases. Okay, so for an example, if you take hydrogen, okay, take oxygen, if you take name any other gas like N2, okay, if you take here 1 liter, 1 liter, 1 liter, got it? If you take equal volumes of different gases, they contain the equal, okay, what they contain? They contain the same number of, what do you call it, particles. I hope you are able to understand this. Okay, so equal volumes of different gases contain same number of particles. I hope it is easy, right? Okay, now one thing you need to fix is that all of the gases that you are taking, they should be at the same temperature and same pressures. If they are at same temperature and standard conditions of temperature and pressure, then only this is valid. Okay, and always remember, just like in a 1 mole of any substance, how many particles are there? Tell me, how many particles are there in 1 mole of substance? 1 mole is equal to any number of particles. Okay, sorry. Now same way, okay, 22.4 liter, always remember this number, 22.4 liter will have what? It will have 1 mole, okay, of that gas, and it will contain the same number of Na molecules. Got it? Always remember, 22.4 liter of any gas comprises of 1 mole of that gas, provided it is at STP. So you can note this down. Okay, now we are done with this particular, what you call it, definition. Okay, let's go on to do some questions. There are 2 questions we need to do to finish this up. So first thing is NEET 2023 at STP. Always think about this. If the question is given at STP or not, okay, you have to focus it, because in competitive exams they might change the conditions. Okay, so then you will not be able to apply that 1 mole is equal to 22.4 liter with Na number of particles. Okay, you can't apply this. Now see, I hope you know what is Na, right? Na is what? It is 6.023 into 10 to the power 23 number of atoms. Okay, I hope you know this. Now see, what is the question? Okay, STP. First of all, verify this question. STP, yes. Now we can do the question. What is the volume occupied by 0.5 moles of a gas? Okay, as in the previous slides, I told you 1 mole is equal to what? It is equal to 22.4 4 liter, right? Then 0.5 mole is equal to what? How many liters? Yes, at STP it is 11.2, half of this. Okay, remember this condition is at STP. Okay, so 11.2 liters, so our 11.2 liters is the option number A. Okay, I hope this question was a little easy, right? Okay, let's go on to the next question. Okay, we have JEE in 2021. The volume of a gas is halved while keeping the temperature constant. The number of molecules is what? Volume of a gas is halved. So we have some amount of volume. Okay, we have some amount of volume. For an example, suppose this bucket. Okay, we compress this bucket. Okay, we compress this bucket, okay, to the half of the initial volume, right? Through some piston we compress this gas. Now initially it was this. Now see, the volume of gas is what? It is half, from V to V by 2, okay, while keeping the temperature constant. So temperature is what? Constant. I hope those who have studied thermodynamics knows what is this, but anyways, the number of molecules is what? What happens to the number of molecules? Is there anything change in the number of molecules? No. Is the number of molecules doubles? No. Halves? No. Remains the same? Exactly. It is remaining the same. And what is changing? So when you lower the volume, the pressure of this particular gas will increase. Got it? The pressure of the gas will increase, but the number of molecules will remain the same. I hope it is understandable, right? Because even though the volume is changing, the pressure will increase, but the number of molecules will remain same. Got it? Now, one thing you need to notice is, you can say it is not given at STP, okay, because the conditions are changing. Conditions are changing, that's why it's not given at STP. So, even though the volume changes, doesn't mean that the number of molecules will change. Got it? Okay. The pressure will rise because the volume compressed, pressure will rise, but number of molecules will remain same. I hope you got to know about these two laws, and if there is any confusion, you can comment down in the section. Okay, then that is it. Take care. See ya. Bye bye. Have a nice day.